All right, so today we're finishing up chapter 9, which we've done logarithms. So the last couple times we met, we've gone through a variety of things, including how to solve problems with the logarithms. We're going to do more of that today. Those are the example problems we just did. So logarithms on your calculator. We're going to be doing some stuff on the calculator, so go ahead and have that out so you're looking at it. As we prep for the exam, remember you got to have an actual calculator for the exam. Cannot use your phones. If you thought you can get by up until now without a calculator, you won't be able to on the final exam. There will be problems that you will have to have your calculator because you do not have the ability in your head to do logarithms. And a lot of other things with exponents you're not going to be able to do. So make sure you have a calculator. If you need to, and again, it can be the simple TI-30 solar-powered, probably $8 on Amazon, which would be cheaper than driving to Target because of gas prices. But if you're looking at your calculator, and if all you have is your phone, in order to see the logarithms, you got to turn your phone sideways. And when you look at your calculator, you will see there that it says log base 10. It says log 10. Log 10 is the most typical way that we do logarithms, which means we don't typically write the 10. So if I write log of x, that means the same thing as log base 10 of x. So if I wrote, come on, pen, here we go. If I wrote log of 8, you would type in the number 8 on your phone and then hit the log 10 button. Depending on the type of calculator you have, you might have to hit the log button first. All right, and that's what it gives you. What does that mean? That means, because it's base 10, 10 to what exponent is 8? And if you did 10 to the 0.9030899 power, you would get 8. Now if you're wondering, how do I do that on my calculator? Not 8, sorry. If I do 10, if you're on a regular calculator, there's a button that looks like that, which is your caret button. It means raise it to a power. You might have another button that's x to the y. So depending, again, on which calculator you have, you'd have 10. Then you would press x to the y button. And then you would press 0.9030899. In some calculators, it's the other way. You'd type in 0.9030899. Then you would press the x to the y button, and you'd do 10. It's all going to depend. There are so many types of calculators out there. I can't tell you universally, here's how it works for all calculators. If you have graphing calculators, it's going to be this one. 10 caret 0.9030899. If I have my phone, 0.9038, wrong number, 0.9030899. Oh, there's a button on my calculator that's 10 to the x. On my phone, if I could actually type in on my phone, 0.9030899, and then I would press the 10 to the x button. And since I rounded, my phone tells me it's 7.99999983975, but that's just because you rounded. If I did the whole number that repeated, and then did 10 to that power, it still gives me 8. But the point being, right here, log base 10 and log when they write nothing are the same thing. All right. Then you have, so then we have this. So go ahead and try each of these three quick on your calculator that you have. And then you're going to tell me what your numbers are after you've done it. But pause, don't shout them out loud. Just do those quick on your calculator. Unless, of course, you look at that and you already think in terms of logarithms. Most people don't. So figuring those out quick, don't say the answers. All right, so in your calculators, you're going to get a number. But again, I'm going to be thinking about what does this mean in terms of exponents and logarithms. So if this is my unknown, the process is when there's nothing written, it's log, so it's log base 10. So I'm thinking 10 to the x power is 10. And so this is my base. That's my exponent. This is what it equals. So that's how we, remember when we did this a couple days ago, logarithms is just another way to write exponents. They're the same thing, two different ways to write it, but we have the different way because sometimes we need to solve for the exponent. And it's easier to do that when I have logarithms. So 10 to the x power is 10. So what number goes in here so that it equals 10? And you put it in your calculator and you found out it equals? Now you can shout it out. 1. There we go. For this one, we're thinking 10 to what power is 0.01. And here's where, if you have a long history of doing decimals, you recall way back in the day, right? The first, after the decimal, this one is the tenths unit, and this one is the hundredths unit. So 0.01 is the same as 1 over 100. 1 over 100 is the same as 1 over 10 squared, because 10 squared is 100. And then properties of exponents, 10 squared of the denominator could also be rewritten as 10 to the negative 2. So when you found log of 0.01, the answer was, everybody? Negative 2. So that's what that means. It was 10 to what power? 10 to the negative 2. Negative exponent meant it was in the denominator. That's how we got it that way. And then lastly, 10 to what power is 1,000? 3. So when we're doing logarithms, this is what your calculator is doing in the background. But we have more than one type of logarithm on our calculator. The other one's called the natural logarithm. The natural logarithm uses the number e. And some people say, what is the number e? Do you know what the number pi is?
3.14.
Keep going. 3.14.
4, 5, 6, 7, 8, 9.
No, not even close. 3.1415926.5. All right, and it goes beyond that. But if I do e on your calculator, if some of you have an e to the x button. So if you do e to the first power, or if I'm on my phones, I type the number 1. And then after I type the number 1, I hit the e to the x button. The number is 2.7182828459045. So e, and it keeps on going, e is the lesser known transcendental number. Pi, most common one. Pi is a number that goes on forever and ever and ever and never repeats. E does the same thing. We use pi far more often because you did geometry and you learned the pi r squared is the area of a circle and some other things related to cones and cylinders, and it's a relationship that goes into circles. E, the natural logarithm, called Euler's constant. You don't need to remember that, but if you're wondering why is it E, Euler, he's the guy. It's Euler's constant. The number e in nat is a very common occurrence in things that use exponential functions. It appears in nature. And then through discovery of the mathematical process, they said, we've actually figured out what E really is. It's this relationship. But log base E on your calculators will appear as ln, natural log. And you're like, wait, shouldn't it be NL? And I know there's a reason for it. I just don't remember the reason. But we do ln for natural log. And it would be the same kind of thing. So if I did the natural log of E, I will get 1. Because I'm asking E, because it's log base E, E to what power is E? I don't know, X is 1. E to the first power is E. All right. So with this, if I did the natural log of 8, and you can do that in your calculators, it's up there just to verify, so you're like, okay, I did it once, so I'm not doing it the wrong way. If I'm on my phone, I go 2.0794, and then I hit the ln key. Oh, other way around. 8. Sorry. 8, and then the natural log key. 8, natural log. Gives me 2.07944154167. And it keeps on going. All right. So here's what that means. E to the 2.079441541679836. That's all the digits my phone has. Equals 8. So that's what it means. Exponents to logarithms, you're going to hear me say it a bunch of times. They're the same thing, just two different ways of writing it. So then I've got this. Take a moment for what we've talked about in terms of logs and natural logs and exponents and converting, and take a minute to see if you can figure out the answer to these two problems. Any guesses or known answers on the first one?
1.0983.
Nope. It is 3. It is 3. Because natural log e to the third, if I want to find out what that is, so natural log is the same thing as log base e of e to the third. And converting logarithms to exponents, this is my base. What a logarithm equals is the exponent. So it's e to the x equals e to the third, because that goes e to the x equals e to the third. So x must be 3, because e to the third equals e to the third. All right. Any answers on the next one? First off, let's think about this. What's another way to write e to the, or the 8th root of e? E to the what? 1/8 power. So I'm taking the natural log of e to the 8th, which will be 1/8. So now, what I'll talk about, the property of exponents on values inside. We did this on the last time that we met. When I have an exponent inside a natural log, this can travel out in front. I could rewrite that as 1/8 times the natural log of e. And then the natural log of e is 1, which is why we have 1 times an 8th, or 1/8. So now, again, this is more calculator practice. A equals PE to the RT. This is another method for calculating interest on loans, total amounts after a principal's been invested. So this is the amount that you're going to end up with. This is the principal or your beginning amount. E to the RT, so now R will be written as a decimal. Boy, that's not coming through. DECIMAL. Decimal. And T is typically years. So P is the amount of the loan. So if you're going to take out a loan at $1,600 times E to the rate is 9%. I need to write it as a decimal. That's 0.09. So it'll be E to the 0.09 times the number of years, which is 5. So in doing this, order of operations, I do what's inside exponents, what's in parentheses first. So I'll have 1,600 times E to the 0.09 times 5 should be 0.45. Then 0.09 times 5 is 0.45. All right. Then you'll do E to the 0.45, which is somewhere around 1.5, something like that. Let's check. Yep, 1.568312185549. And then multiply by that 600. So A equals, this should equal then 2509.30. Since we're talking dollars, we'll just end our rounding there, which is that number here. So again, this is just getting you to say, okay, if that's my equation, here's how I do it. I've practiced using E. So when you're working on the check your understanding problems, you're not looking at them going, what is that? I have no idea what we're doing. Now you know. So properties of exponents, quick reminder. Let's see, if I have a to the 10th times a to the 3rd, that will equal a to the 13th. When same bases multiply, we add. A to the 10th over a to the 15th will be a to the -5. When we divide same bases, we're subtracting. When I have a to the 3rd times, or to the 12th power, I would have a to the 36th power. Powers raised to powers multiply. And then if I had a to the 3rd plus a squared, that will simplify to a to the 3rd plus a squared. There's nothing you can do. Only when we multiply and divide can we do anything with my exponents. Properties of logarithms. We did this the other day. Log of AB is equal to log of A plus log of B. So when I'm taking a logarithm as being multiplied, it's the same thing as adding. It's the same idea as when I have same bases and multiply, I add the exponents. When I have same bases and add, I multiply. If I have log of C over D, that's equal to log of C minus log of D. And then the last one, log of x to the y power. That y can travel out in front, so I'd have y equals log of x. And how we're going to use it, and then change of base. People were asking me the last time, what if if I had log base 2 of 9, how can I use my calculator to solve it? I would have to use the change of base formula. So this would become, for this problem, log of 9 over log of 2. And then I go to my calculator, find the log of 9, and then divide by the log of 2. So that's how you'd have to do it. All right. Much like you can't reduce anything here because this is a function. It's not multiplying. It's not log times 9. It's log of 9. It's a function. So that's what we'd have done there. Log base 4 of 7 is log of 7 over log of 4. So how do we do that? We're going to use that then to solve for things like this. So natural log of 3x equals 0.18. I'm going to rewrite it as the natural log of 3 times the plus natural log of x. When they multiply, it can be split into adding, equals 0.18. And the natural log of 3 is an actual number. It's 1.0986122, something like that, plus natural log of x equals 0.18. Going to subtract this from both sides. So 0.18, ooh, come on calculator, 0.18 minus, and that will be natural log of x equals negative 0.9186122888. And now we're back to, I have a natural log, which is a log, and I have an equation going on, and if I don't know what to do, right, this isn't multiply, so I'm not dividing by natural log, I am going to rewrite this as an exponent. My base is e. This over here is my exponent, because whatever a log of something equals, that equals thing is the exponent. So it's going to be e to the negative 0.9186122888 equals x. So converting between natural logs and exponents is how I'd need to solve this one. And now, e is a number, the other one's a number. So if I do that in my calculator, e to that power, I find out that x equals 0.3990724, and there's a bunch of other decimals after that. If they have the same bases, and it's just one singular log, if the log of x is equal to the log of y, then what must be true? What do you think? If you take the log of x and the log of y and they're the same thing, then you must have taken the logarithm of the same thing. So then x equals y. All right, so here we're going to, when in doubt, if you have multiple logarithms of variables, if there's a way to combine them into one, that's best. So here I have logs and I'm subtracting. Subtraction is the division, so this can be combined together to be log of x plus 2 over x. This will equal 2, because it says equals 2. So now I've got them two together, and I have variables inside the logarithm, so I'm trying to think, is there a way I can get rid of the logarithms to do something different? This is log base 10. So 10 is the base. What it equals is the exponent. What the whole logarithm equals is the exponent. And then it will equal what's inside. So 10 to the second power, 10 to the second power equals x plus 2 over 2. Well, now I've just got numbers and variables. Not 2 in the denominator. That's supposed to be an x in the denominator. Sorry. X 100 equals x plus 2 over x. I'm going to multiply both sides. I keep making it a 2. I'm going to multiply both sides by x, because on the right side, these x's will reduce. And I'll have 100x equals x plus 2. Ta-da. So in a problem like this, you'd be assessed, do you remember what the properties of logarithms are? So when I have logs of the same bases and subtract, that's the same thing as dividing the one thing together. Can you change from logarithmic into exponential form? And then once in here, I've got fractions. Do you remember what to do with fractions as we solve equations? So while we started out at the beginning of the semester with questions like this, we were just solving simple linear equations, in one question we can be assessing multiple chapters and concepts worth of work. I mean, you can guess where this is going next, or might be going next. You're like, oh, if this and what I end up having over here is a quadratic, then we're going to add quadratics and factoring into a logarithm problem. It all becomes built upon each other. Same bases. Pluses multiply. It will be log base 2 of x times x minus 1. This times that equals 1. Going to change it now into exponential form. 2 is the base. 1 is the exponent, equals x times x minus 1. Two equals x squared minus x. Oh, look at that, it's quadratic. 0 equals x squared minus x minus 2. Just move the 2 over. Can I factor? I hope so. If not, then I have to use the quadratic formula or completing the square. But in this case, let's see, two numbers that multiply to -2 that add to -1 are -2 and +1. 1 times -2 is -2. 1 plus -2 is -1. Then lastly, I need to identify my answers. X equals 2. Because if I put 2 in here, 2 minus 2 is 0. 0 times something is 0. X equals -1. Put -1 in here. -1 plus 1 is 0. 0 times something is 0. 0. So these are my two answers up here. All right. Yes, we do. How long does it take for an investment of $2,000 to double? So my end amount is doubled. 2,000 equals 1,000. My interest rate is 5%. As a decimal, that's 0.05. Slightly different equation here. The n is the number of times it's compounded in a year. So this says compounded quarterly. So n is 4. And then my exponent would be 4 times t, which is the number of years. So if this were a particular question on an exam, I would be giving you this. And then you'd have to remember what goes into what parts and pieces for solving this equation. All right, so now I'm going to solve for t. T is in the exponent, which means I'm probably going to need to use logarithms eventually. I'm not going to say that's a rule, but that's typically what's going to happen. So if you're thinking about what am I going to write on that one full page of notes I can have front and back for the final exam, might not be a bad idea in the little section that you title logarithms to say, when my question has a variable in the exponent, I'm going to use logarithms. All right, but now I got to solve for t. Much like an onion, we got to go outside in. Got to work with the outside stuff first, which includes the 1,000. Got to get rid of the 1,000. Divide by 1,000. 2 equals parenthesis. And now this right here, I'm just going to 0.05 divided by 4 is 0.0125. So this equals 0.0125. So inside the parentheses, I have 1.0125 raised to the 4t power. Now, I am to a place where I have an exponential function. I'm going to now convert this into a logarithm. So, I am going to do it one of two ways. I'm going to do it over here in green. I could do log base 1.0125 of 2 equals 4t. All right. And then change of base, because our calculator does not have this. So I'm going to rewrite that. And all this is here on the left side, this is just a number. No longer have variables there, so I'm going to make that into a number using the change of bases. So I'm going to do the log of 2 divided by the log of 1.0125. If I do that on my calculator, what is the log of 2? 2 log is 0.301029999. I'm going to divide that by 125 log equals 55.7976. It would be a good idea to verify that you got that same number in your calculator. Equals 4t. Now, algebra, divide by 4. T equals 13.949. So to answer the question, how long does it take for an investment of $2,000 to double at 5% interest? Takes almost 14 years, 13.949 years for $2,000 to double. So again, if you invest money towards retirement, you put it into something that earns 5% interest over some time, it'll double in that amount of time. So using that, I'm just going to write down the equation here. A equals P times 1 plus R over N to the NT. Doubling, that stays the same. This stayed the same. 1 plus, the rate's now 5.5%, so 0.055 over 4 to the 4t. This will be 2 equals 1 point, what's 0.55 divided by 4? So this would be 0.1375 to the 4t. Log base 1.375. 1375 of 2 equals 4t. Convert it. Log of 2 over log of 1.1375 equals 4t. You find this number divided by 4, and it's 12 point, what was it? 689, something like that? So you shave over a year off of the fact that you can double it with just 0.5%. Don't forget to check your understanding problems. Keep it up on the work.